Easter break.
Well, they try to balance the terms number of days. And then, I think they kind of try to match up with UNK for spring break. So you got two different things going on. That's why. It seems like there was 1 year where our spring break was different than UNK's, and that caused all kinds of problems.
You're not going to sign anyone over spring break, are you?
Great. Yeah, mine. Well, it's not that big a deal. You would do it like you always do. You do it like that Sunday night. 11 o'clock. Well, wait a minute. We don't have school that Monday.
No. No, the next Friday. We have a spring break and then a 4-day week. Friday off and then the Monday off, 4-day week.
Well, wait, no. So we have a full week next week. Spring break. But then the Monday after spring break, we don't have school, right?
No, it's the next Monday we don't have school.
The next
We have a 4-day
we
week.
come back and we have a 4-day week. We have Friday, Monday.
Why?
Because of holiday.
Oh, that's right. You're right. So we come back from spring break. We have school Monday through Thursday. Friday, that's Good Friday.
And then the Monday.
And then Monday you don't have school. We do. I think you don't. And then the Tuesday is the ACT day.
Oh my.
Tuesday's the ACT day. So we only have like a 3-day. School week. Just have to
Oh,
count.
that's a school day right there.
That is interesting.
Yeah, that does count as school day. Okay. Yes, I agree. I'm sure there's some of you, this is less convenient, but whatever, that's how we're going. You gotta get it made up. Okay, so what I want you to do, where were we at? I totally lost.
What are you doing?
Oh, the worksheet. No, not the worksheet first. Okay, so these will be provided to you for the quiz, one way or the other. I'll have a sheet to hand out to you, or I'll just have them up here on the screen if we're doing it in here. And so those will be there. These, we've been skipping these. Not that they're that big a deal, especially when I just gave them to you, but we're not going to have those on the quiz. Okay? I don't think they've showed up in the homework or anything either, have they? So I gave them to you just in case they accidentally, I missed one or something that showed up in the homework. Okay, so yesterday we went through this, so if you got to watch the video from yesterday, we said, so this added kind of a new thing for solving, where we have this plus in here. We kind of went through one way to do it, kind of the way we were doing the cosine 2x and 3x ones, but we found out that was a little more confusing. It seems much simpler to just do this new identity we learned, which is this one. So we just go through and expand it out, and it just simplified down to this, which was pretty nice. And then if you had one like this, you really wouldn't even have an option to do it kind of an old way. The best move would be to do this. Now, a comment we did make yesterday is this: it's easier here if you don't put square root of 2 over 2 in here right away. It's easier if you just notice that those two just cross out. And then that these two you can add together like that. That makes it easier. Then put your square root of 2 over 2 in there. And then you divide, and it ends up being this, actually. And then it's just a pretty simple problem from there. So we're going to do no calculator on the quiz, so it'll end up being problems like this that we've got. So something like this could be in there, but there's also going to be some simpler ones. Okay, trying to give you a second chance at the last quiz, right, that we took. Some of those problems, that we can fix some of those mistakes we made, either the factoring, or the getting the right quadrants and those kind of things. But with a few new things plugged in. Okay, so let's do this real quick. This is all good review at various times. You're not going to, on the quiz, we're not going to have just problems like this, but these types of things come up, knowing these values, especially in a no calculator. So this is all no calculator. So knowing these things in a no calculator situation are useful. So, and sometimes we get so caught up on kind of the main focus of what the quiz is going to be, but then when we get a little something out of the ordinary or something from the past that we haven't talked about for a while, we forget about it. So it's good to look at things. Which one do you want to talk about? Which one?
Number 5, there will not be no solution because group of 2 is bigger than 1.
Number 5,
Secant.
it's secant. Cosine has to be between -1 and 1, so secant's reciprocal, so secant means it has to be bigger than 1 and
okay.
bigger than or less than -1. But it's just the reciprocal of cosine. And -45 is in the fourth quadrant, cosine's positive there, so it'd be root 2 over 2. Flip it. 2 over root 2 would be fine. Okay, so cosine 60 is 1/2, that's easy, first quadrant. Sine 3/4, second quadrant, that's root 2 over 2. Tangent, remember sine over cosine. So sine of 3π, which is down there, that's -1, sine's the y, so that's -1. And cosine of 3π is 0, so it'd be -1 divided by 0, that's undefined. Cotangent would be cosine over sine. So cosine of 90 is 0, sine of 90 is 1, so 0 divided by 1 is 0. That's how I would do cotangent, cosine over sine, for that one. Okay, and for this one. Secant we just talked about. Cosecant of 0 would be 1 over sine of 0. 1 over sine of 0, which is 0. So 1 over 0 is undefined. Arc sine of root 3 over 2. So the sine whose, or the angle whose sine is root 3 over 2 would be 60 degrees or pi thirds. Didn't really tell you whether you're just supposed to be radians or degrees, right? So you would, you would pick one. We usually do radians if it doesn't say. Arctan -1. Now that was the one I was wondering if you guys did that, right? Did everybody get negative pi fourths for that one? That's a tricky one. Remember we said arctan and arcsine always have to be in the first or fourth quadrants. Remember that negative pi halves to pi halves thing? Sort of, Okay, not really. Okay, arcsine and arctangent. The positive. Remember we had to restrict the domain. So the positive ones are first quadrant, the negative ones are second quadrant. So where is fourth quadrant? So where is tangent negative? In the second and fourth quadrants. We got to go fourth quadrant, but we got to have our answer between negative pi halves and pi halves. So that's different than what we've been doing. When we solve equations, we've been wanting to be between 0 and 2 pi. So we always want the positive value. We got to go around the circle, right? But with this, we want to be in that fourth quadrant, and we want the negative value, so we want to use negative pi fourths. And you can try it on your calculator. I think that's what it'll give you. If you're in degree mode, it'll give you negative 45. Okay. Our cosine 0, now remember our cosine is, we got to go from 0 to pi. Our cosine is the only one where we go 0 to pi. First quadrant positive, second quadrant for the negatives. Well, our cosine 0, where's cosine 0? That's straight up at pi halves. Now it's also 3 pi halves. But we want to stick between 0 and pi. So we get pi halves, right? And then cosecant of 2 would be the same as arcsine of 1/2, which is pi 6. So that maybe was the trickiest one there. But, all right, so that's kind of some review stuff. Okay, what about the worksheet? Which one did you say in the worksheet? Number 10, and which side?
Could we do either of the tests?
Could we?
Yeah,
You mean, were we capable of doing it?
I didn't.
Yes. Do you have the knowledge and the wisdom to do the 10s? I say yes, but you may disagree. All right, let's look at it. So it says, an engineer is designing a part of a blah, 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 blah. Find the exact value of sine of angle ABC. So what is the exact value of angle ABC, which would be sine of 45 plus 60. That's what you would do. So you would do sine 45, cosine 40, or 60. What is it? Plus or minus? Plus cosine 45, sine 60. So root 2 over 2, 1/2, root 2 over 2. Right? So root 2 plus root 6. Oh, geez, we see that one. Okay, and I'm guessing the other 10 was similar. So this would be, well, now this was a little trickier because we can't do 75. So 30 plus 75 is 105. So how could we do cosine of 105? Rewrite it as 45 plus 60, right? So they gave us 30 and 75, but 75 is not a number we like, so we'll add them up, that's 105, and then we could just do this. So that'd be cosine 60, cosine 45, minus sine 60, sine 45. So, hang on. So, 2 minus root 6. So, okay? All right. Any others? Any others?
5 on the front page.
Okay, so this is that this is that find the exact value. Did we, yeah, okay, 5. So this one, yeah. So anytime, what we talked about yesterday is anytime you see this and then they give you a quadrant, that angle, draw a triangle, draw a triangle, draw a triangle. Especially if this isn't one of our root 3 over 2 or 1/2, root 2 over 2. If it's not one of those, or if it's a tangent and has a root 3, right? Those are our nice ones that we could just, we just kind of have memorized. Okay, but if you get one like this, it says cosine, it says alpha's in between pi and 3 pi half, so that'd be third quadrant. So that means we're going to draw a triangle. It's going to be negative 15 over 17. 17 is always the hypotenuse. Hypotenuse is always the hypotenuse is always at the bottom number. It's always positive, so the negative has to be on the 15. Do your Pythagorean theorem to this. Now, those are a little bit big. I told you it's going to be no calculator tomorrow, and you're going to probably have to do some working out by hand, right? Some multiplying. So 17 squared is 289 minus 225, and that is what, 64? So that's nice. That's it. Okay? And that'd be negative, right? And then this other one, tangent is negative 12/5, and that is between pi halves and pi, so that's second quadrant. Tangent is opposite over, now that would be silly of me, look what I just did. I'm used to putting the negative on top. Why would that be silly? Because it's going up. So why would you do that? So the 12 is positive, so it's opposite over adjacent, so it's 12 over 5, right? And so we get this, and I believe that's 13. That'd be 25 plus 144 is 169, which is square root of that's 113. So it'd be nice to know some of those Pythagorean triples, right? 3, 4, 5. If they don't work out, if you get a square root, that's fine. You get square root of 30 or, whatever, then use it. Just use square root of 30. You don't have to simplify it. But 3, 4, 5 is one. 5, 12, 13 is one. We just saw here that 8, 15, 17 is a Pythagorean triple. So those are nice ones that show up a lot on these problems. So if you know those, you don't have to do the arithmetic on them. Okay, but anyway, so now, yeah, and so we good? You good from there?
Yeah, then you just multiply them out.
So now you write out, so you would have what? Sine alpha, cosine beta, plus cosine alpha, sine beta, right? Like that? Yeah, so sine alpha would be, this was alpha, right? This is our first one. So sine would be negative 8/17. Cosine beta is negative 5/13. And then cosine alpha would be negative 15/17. You should always get common denominators. That should not be the issue. Sine beta is going to be 12/13, right? Yeah. So now you're going to get 40, and then what is that? Big number, 221. Yes, you do have to do some multiplication. Minus 15 times 12, 180 over 221. 40 minus 180. There you go. Now, I don't envision giving you great big numbers, a bunch of great big numbers you have to do. But, good. That was fine. That was fine. And I have the answer key here, so if later here when we're working, if you just want to look over all yours, you can double check. Okay, what you got would be a good idea. Okay? All right. Anything else? Yes. Which side? Which one? This 9 right here. So, identity. So, what we're going to talk a little bit after lunch, what's on the quiz for sure. But I mean, it's basically identities, a little bit, equations more so, and then these new identities we've learned, which could be in either one of the potential problems. It could be the problems that we've just been doing with the identities, like the one we just did, right, where you expand it out and just do that. So anything where you draw the triangles, where you just have to recognize, we'll do some of those here in a little bit. So some of the old and then some of the new with these new identities mixed in. Okay, so you would just take the top and work that out. So it'd be sine alpha cosine beta plus cosine alpha sine beta all over sine alpha sine beta. And then this is cotangent, so this would be cosine alpha over sine alpha, probably what I would do on that. And this would be cosine beta over sine beta. So that's one of the things we haven't done much of, is where you have, we've had problems where you had cotangent x plus cotangent x. So that's 2 cotangent x. You can add the 2 cotangents together. But not if they have different angles inside of them, right? So cotangent alpha plus cotangent beta you can't add those together, right? They're different. And so that's important. So that's not something we've had much of before. So now what would you want to do with something like this? You got 2 choices. You can work with this side right now, or you can work with this side. Right side? If you're going to work with the right side, what do you need to do? By getting common denominator. So a lot of you would think to do that, common denominator would be those 2 together, or bow tie if you want to think of that. But you're going to do a sine beta, top and bottom, and you're going to do a sine alpha, top and bottom, right? And so what's that going to give you? It's going to give you sine beta cosine alpha plus cosine beta sine alpha all over a sine beta sine alpha. Now, I probably should have been smarter and rewrite that. I did tell you I want this side to look exactly like this side so that a 3rd grader could look at it and see it was the same. Yeah, I'd probably be a little lenient here. I mean, sine alpha, sine beta, they're just flipped. That's fine. Here you got sine alpha, cosine beta. That's actually this one over here. Okay, and cosine alpha, sine beta is this one. Okay, so, if it was a quiz and it were me and I had time, I would probably make sure I rewrote them so they look the same just to be sure. But yes, they definitely are the same. Or what could we have done if we worked with the left side? What could I have done with the left side here? Remember what we said with a fraction with a single denominator? Remember to split it apart? I could, if you have 3 plus 4 over 7, you can write that 3 sevenths plus 4 sevenths like that, right? So we could take this and go sine alpha cosine beta over sine alpha sine beta. And then I could have done cosine alpha sine beta. You have to be careful with this, that you don't screw this up or you did split it wrong. So if you're not familiar with it, if you're not comfortable, do the common denominator, what you did on the right side. But right here, these sine alphas would cancel. So we get cosine beta over sine beta. Well, that's that red thing. And then right here, we get a sine beta and a sine beta cancel. So we got cosine alpha over sine alpha, which is this. So now we end up here with the red. So we could have done that. We could have split it and done that, or we could have got common denominators and showed it there. So either one would work then. Okay, and this one I said we could do. It was crossed out. I don't know why it was crossed out. I think it's because of tangents. I think whoever originally got this worksheet thought we couldn't do it. But you can do that. You can turn these into sines and cosines and get common denominators, and then it'll look like this side. Or you can just expand this out. Well, actually, that's probably what you need to do. You need to do this side, sines and cosines, and get common denominators, and then expand this out nice and tough. Okay, when you get common denominators, what will happen is they'll cancel. Okay, you can invert and multiply. All right, anything else? Other side. Okay, so if I'm looking at this, I'm probably not going to do anything with this side just yet. I'm probably going to have to turn those into sines and cosines, I'm guessing. Yeah, as a matter of fact, I'm going to do that because I know when I work this out, you're going to have some sine cosines. So let's do this. I would say sine alpha cosine beta maybe distribute would be smarter. So let's do that, times that, and then times that. So when I times that by cotangent, that's cosine alpha over sine alpha, like that. Okay, and then it's going to be minus, I'm not going to have room here. And now let's do sine alpha, cosine beta. I think this is a smart way to do this one. So I'm going to do sine alpha, cosine beta, because they're times, so I can keep them together. It's kind of like having a 3x, right? I can keep that together. So that times tangent, which would be sine beta over cosine beta. Because what happens in each one of those terms here? What happens here? Don't those sine alphas cancel? And so you get cosine alpha, cosine beta. I'm writing the alpha first because I'm looking what's going on over here. But I got cosine beta, cosine alpha, so I wrote the cosine alpha first. Then I got a minus, and what happens here? What happens in this one? Cosine betas cancel. And so I got minus sine alpha, sine beta. Right? And that. Now I got a choice, so I can come over here now and I can rearrange this. I could expand this one, but didn't we do some exercises where we had to recognize this as one of these patterns, right? Doesn't this look like the cosine one, right? It's cosine, cosine, and then sine, sine. When it's a minus in there, it's a what in here? It's a plus in here, right? So this one is cosine alpha plus beta, and that's a match right there. So that probably would have been the way to do that one. You know, I could have turned this into cosines and sines. I could have went cosine alpha over sine alpha, sine beta over cosine beta, got a common denominator. Maybe some of you tried that. That would have been okay. If you didn't think it distribute, you could have got this sines and cosines, got a common denominator. And the nice thing about that then is you'd have had some stuff canceled. You'd have had some stuff canceled. Okay? And then you'd ended up in the same place. Okay? All right. Let's do 2 and 3. 2 and 3. got for the first one? 1. What do you got for the second one? Isn't it 1?
Yeah.
Now, you don't have to write 1. Actually, you probably shouldn't write 1 for the second one. Well, we'll get to that. Okay? Here is number 2. Is that how we're getting 1? I draw those right? Alpha's in quadrant 3, beta's in quadrant 4. What?
I got negative.
The sign of P should be negative.
Right here.
Yeah.
And your 3 should be negative on the other side.
When you go down, it's negative.
3 would
Since
be,
when?
3 would
Your 3 is
Yeah.
on your alpha.
Oh, I did that.
See? See? Not the only one. Thanks, Caleb. So I just kind of botched this all over the place.
I got
So-
the numbers.
I got, yeah, I got -1.
Oh, I forgot the negative 3.
Right, it should be -1. So this would be -9/25. And this is, these two make a positive,
But you're subtracting.
but you're subtracting. So really you have 3 negatives there.
So it makes it.
So it makes it negative, right? Because this would be -4/5, and this one would be -4/5. So -9 minus 16 is -25/25, which is -1. Yeah, wow, I did really good there. Okay? And the last one really probably should stop with sine of pi halves, but if you're showing your work and you go to 1 as the answer, I'm fine with that because you should have sine pi halves on your paper. When it says right as a function of a single angle, that's what we're talking about here is a function of a single angle. I wouldn't want you to stop here. I wouldn't want you to stop here, right? I mean, those are right. That's correct. I'm crossing them out, meaning I don't want those to be your final answers. So write it as a function of a single angle. Yes, it's sine of 2 pi thirds minus pi 6. Because you look at the pattern, it's a sine one. And when sine's got a negative in the middle, it's a negative in the middle here. And so you got to take 2 pi thirds. So that'd be 4 pi 6 minus 1 pi 6 is 3 pi 6. 3 pi 6 is 1 half, pi half. And then sine of pi halves would be 1. But I'm fine if you leave it right there. Okay, we're going to get started with this. You can work with a partner or 3 in a group. I don't know, 1. You can do it by yourself. I got some dominoes here. These are equations. That was one of the big things we messed up on the last quiz a little bit. So we got some equations. So just take a set. Okay, that's setting here. There's some dominoes. So you get the equation. You solve it from 0 to 2 pi. You find the one with the answer. We'll start it now and we'll carry it over after lunch.
You have to ask permission. Yes, you do. Yes, you do. You're going. That's
Yes.
Nick just kind of follows whatever I say, so.
When did you want to
Are we actually gonna play dominoes?
Okay, but what if we just stand and keep it all right?
You have to solve, okay, so you can solve from 0 to 2 pi and then find the answer.
That's not how you
They don't stand up very well.
Yeah. How am I supposed to do dominoes when they won't stand up?
Yeah, exactly.
Ballsy. I'm telling you. You're supposed to each get like maybe all have 4. And then one puts it down, and then whoever matches and do that.
Then they wanna stay for like.
You gotta find your buddy. Like Domino's is the right one. Yeah. Come on, I'd lock you in that room.
You almost got me.
What? Roxy.
Too drunk.
No, it went behind you.
You got your nights.
Yes.
No, I got that one back door.
Wait, I gotta edit.
Oh, it's so soft.
Wait, so this is gotta be that.
I don't like proving. I do like proving myself. I don't like throwing things.
You have to subtract the sign.
Oh, that's just hard. Can you change it down
Equals 0 and cosine minus 1.
It's been a week.
It has been a week.
It's not sine plus cosine. You have 3x and you subtract it. It's not.
I feel like we need an automatic change.
Yeah.
That's
Like your mouse.
like a paper one that you just automatically just like.
You subtract the sign.
Because like we just only like that 30.
Yeah.
It's totally paper, that's.
Yeah, yeah.
Like you didn't tell the time it would just know.
Yeah, it just goes.
Some special paper that would dissolve or something.
Like slowly, like as it like goes, like slowly develops.
But in February, we'd have to dissolve faster. That paper would have to dissolve faster.
Well, you know,
Yeah.
the future of calculus.
That's what we mentioned right there.
I don't like What's that?
Just has to be on there. Wait, where did it come out? Yeah, I mean, and where it is. You, like, just right there.
Your cell phone? Optional review problems. I'll put it.
Oh, it's optional.
I love
Optional. I say, the words come out optional and they go in as no homework,
Because I understand that.
right?
If I feel I need to do it, I'll do it.
We have big cooks.
Wait,
Atta boys.
so if you
Oh man, that's so far back.
Wow.
I think so.
Free sun. Yeah.
So, how's this gonna work for the test today? Do I come into here during study hall, or will you give it to my teacher?
No, you come in here,
Alright,
because I don't have a class. So,
just want me to come here right at the bell and get a pass, or give him a pass.
let me get you, who else is doing this?
Kale. Kale,
You're coming in to do the, Kale, you're coming to do the quiz for us?
are you coming to do the
Probably.
quiz?
I am.
Yeah,
I'm coming tomorrow morning.
Yeah, I'm okay tomorrow morning.
Why isn't it?
so
why is it
just
not-
me.
You're coming tomorrow morning.
Sine function, but it's one meter right?
I agree.
So that's right.
Sine is so little.
Alright.
What if I don't practice today? 'Cause I know it's gonna
It was just cosine.
third day in a row.
It was just cosine X, yes.
You're gonna lift today?
Probably, it's still windy and we're not like.
It is not.
So it's
You guys are just wussies.
Throw the
No,
shot.
we put up, we actually not even.
You can throw the shot.
I mean, we can, but like there's not enough.
I thought you were throwing the discus without.
Smart. We're considered a danger. It's like, we're considered a danger without it. Sure.
Yeah, exactly.
16.
Right?
GPS.
Yep.
None.
Wait, we don't even have to do that one. We don't have to do N7.
Oh.
I was gonna say, I don't remember doing this.
All right, go ahead.
I was gonna say, I don't remember doing that.
Let's finish up here. Check. Yeah. All right, and you guys can finish that one. I just want to make a couple comments. Yeah, so we'll have 45 minutes for the test quiz tomorrow. So we get in here at 11:05, and then a few minutes to get it handed out, whatever. So if we get started by 11:10, period ends at 11:55, so it's 45 minutes to get it done. And then after lunch, it'll basically, we got some new IXLs there, or if you still haven't finished the old IXLs, that'll kind of be work time for those things, okay? So, yeah.
When are those IXLs due by?
Which ones?
This term.
Those are you.
Right here above the line?
Yeah.
Due tomorrow. I mean, now. I might be looking at them tomorrow afternoon, 4 o'clock.
So the 01, 3, and 4.
Right. They have time. I probably have time. So, I guess we could say by midnight on, the term actually ends, right, at midnight? No, I think probably at 1 o'clock, but whatever. I want to talk about this right here then. So this one, just turn sines and cosines, flip that up, cancels, that's pretty easy. This one is one we had done quite a bit, draw the triangle. Now this would actually be, sine is 1/2, that's actually like pi 6, we would know that, but for purpose of this problem, we don't need that. Okay, we can just do the 1 and the 2 and the root 3, that thing. But the one I really wanted to point out was 3. 3 is the one that we've had some issues with, right? You do not want to divide by sine here on 3, right? It looks like you could divide by sine, it would go away, but you would lose solution then, okay? So what you want to do is you want to move things over. So if you're tempted to divide, make sure you can't subtract everything, get 0 on one side and factor. That's a better option. Now we did do the example of a tangent one. If you had sine on one side, cosine on the other, divide by cosine and turn it into tangent. That's a possibility. But that's because if you move everything to one side, you can't factor anyway. And so that's what you want to do. You move everything over, then you can take out a sine, get 1 minus cosine. That's what you want to do. Because then you get sine is 0 or 1 minus cosine is 0. Now you add the cosine over, you get cosine is 1. So when is sine 0? That'd be at 0 and pi. When is cosine 1? That's at 0. So your answer is 0 and pi. Okay, because you get 0 twice there. If you divided by sine, you would have lost the pi. You would have lost 0 and pi, so you just had, okay? So, just to make sure, just to double check people again on that one. All right, so optional, hate to do optional, but it's all right. So, Cash, come on. All right, so all I did here is on page 418, which is the chapter review section, these are the problems that would be similar to what is on the quiz. Okay? Now, obviously, that's a lot of problems. I mean, you're not going to go through. You certainly don't have to do all or don't have to do any, to be honest with you. It's up to you. But you got identities, you got some equations, and you got some sum and difference.
You marked this.
Did you go down there already? You were just going to go down and then tell her you're going to be here?
Yeah.
That's all you were going to do?
Well, I have to, I'm switching classes for my next first block, so I have to pass her.
Oh, okay. All right.
I was in
Homework, Ally, did you have that homework from yesterday?
Yeah. You wanna?
Jack, did you have that assignment?
Feet away from
That was due yesterday.
Are trying to be harmony.
Do you have it?
No way.
I don't believe that.
I have some standards. There it is. Okay. All 3 pages of it. Yeah, he wrote everything out. What'd you say when you came over? He's gonna be in our home. I think you're with you last week.
I knew you were gonna say it.
Disappointing our parents.
Now I got a waste to do.
Ryan, missed you last night.
Yeah, my mom didn't remember it. I was after school went to bed.
Diego, missed you last night.
I know.
No, I'm gonna text your sister right now. Text your sister.
That's pretty weird.
Text your sister. Oh, yeah,